Hello, welcome to A-Level Mathematics. Today we will discuss about algebra and functions. For most of you, this is actually like a revision from SPM or O-Level. After completing this chapter, you should be able to 1. Simplify expression and collect like terms. Apply the rules of indices. Multiply out brackets. Factorize expression including quadratics. Manipulate surds. This chapter provides a foundation for many aspects of A-Level mathematics. Factorizing expression will enable you to solve equations. It could help sketch the graph of a function. A knowledge of indices is very important when differentiating and integrating. Surds are an important way to give exact answers to problems, and you will meet them again when solving quadratic equations. Simplification, expansion, and factorization. You may require to simplify an expression. 3x squared minus 6x plus 4 minus 2x squared plus 3x minus 3. You may collect the like term by rearranging the form. You may arrange by starting with x squared term, 3x squared minus 2x squared, followed by the x term, minus 6x plus 3x, followed by the number 4 minus 3. That's equals to x squared minus 3x plus 1. You may also require to expand expressions, and you're actually supposed to simplify if possible. For example, 2x times 5x plus 3 minus 5 times of 2x plus 3, which is equals to 10x squared plus 6x is actually from the first bracket 2x times by 5x and 2x times by 3, followed by minus 10x minus 15, which is the minus 5 times 2x and the minus 5 times 3. Please aware that the negative sign outside of the bracket change the sign inside the bracket after expansion. Furthermore, you simplify the like term, you have 10x squared minus 4x minus 15. You are also required to factorize expression. For example, x squared plus 6x plus 8. And you should aware that 6x can be split into 2x plus 4x, y2 and y4, because we will want to factorize into the common term to find the common factor. X squared and 2x we can factor out x, and 4x plus 8 we can factor out 4. Hence we will have x times by x plus 2 plus 4 times by x plus 2. The x plus 2 and x plus 2 will serve as another like term. Hence we factor out it again. We will get x plus 2 times by x plus 4. Let's revise some basic algebraic formulas, such as a plus b the whole thing square. After we expand and do the algebra, you have a squared plus 2ab plus b squared. A minus b the whole thing square. After expansion, you have a squared minus 2ab plus b squared. A plus b the whole thing power 3 equals to a cubed plus 3a squared b plus 3ab squared plus b cubed. Maybe you'll find it's hard to remember this formula. All you need to do is just remember the figure 1331, and the a is in decreasing power starting from 3, 2, 1, 0, and B is in increasing power 0, 1, 2, 3. Same as the A minus B to the holding power 3. As you can see, the figure and the power is just the same, but the sign is different. Compared to the previous, the A term will always be positive, followed by negative, followed by positive, followed by negative again. Or you may expand A plus B times by A minus B, and you will get A squared minus B squared. Or A plus B times by A squared minus AB plus B squared is actually A cubed plus B cubed. This formula is more useful for factorization. And the last one is A minus B times by A squared plus AB plus B squared, which is A cubed minus B cubed. Now let's revise some rules of indices. A power m times by A power n. We'll see that we have the same base A, with first power m and the second power n, and we can write them as A power m plus n. A power m divide A power n. Again, it's the same base A, and the power we can write as a subtract, m minus n. Followed by, if we have A power m and power again by n, it's actually A power of mn. Okay, as you can see, the power inside the bracket and the power outside the bracket be multiplied together. And we'll have A power by negative m. The negative with attached to the power is actually indicating a fraction as a denominator, 1 over A power m. And A power 1 over m. Now the power is a fraction. This is just the m root of A. If m is 2, then we have a square root of A. If m is 3, we'll have cube root of A, and so on and so forth. And if we have A power by n over m, we can write in this form, where m root of an or m root of A power n. If we have A power by 0, it will always equals to 1. Any base, any value that power by 0 will always equals to 1. And A power 1 will just be A itself. If we have a different base with the same power, A power m times by B power m, we can actually multiply the base together and write a single power m outside the bracket. Similarly, if we have a square root of am, we can actually split it by writing square root A times by square root B. If we have A power m divided by B power m, which is different base and same power, we can write them as a single fraction that power by m. Similarly, if we have a square root of A divided by B, which is a fraction, we can write them as square root of A divided by square root B. Now we follow by manipulating sets and rationalize the denominator. In A levels, most of the time you are required to write in exact form. Hence, you will need to know how to manipulate sets to find its simplest value and rationalize the denominator to find the exact answer. You can plain simplify a value by manipulate sets, such as find times of square root 6 minus 2 times of square root 24 plus square root of 294. We have the square root 6, square root 24, and square root 294. How do we simplify it? For 5 square root 6, we can just remain as is, and 24 we can split into square root 6 and square root 4, and square root 294 you might need to do a little bit of calculation to show that it's a 6 times 49. And you should aware that all three terms have the square root 6 as common factor. We can factor out the square root 6, and inside we're left with 5 minus 2 square root 4 plus square root 49. By simplifying the value and do your calculation, we have 5 minus 4 plus 7, which is 8. Or we should write as 8 in front of the square root. You can rationalize the denominator of a fraction when it is a surd. The rule to rationalize surds are: you have a fraction in the form of 1 over square root a, just a single term in the fraction. You can multiply the top and the bottom by square root a. You have fraction in the form of 1 over a plus square root b. You can multiply the top and the bottom by a minus square root b. As you can see, you're just changing the sign at the back term. If you have fraction in the form of 1 over a minus square root b, you can multiply the top and the bottom by a plus square root b. Let me show you an example. We would like to simplify square root 5 plus square root 2 over square root 5 minus square root 2. All you need to do is just observe the denominator. You'll observe that the square root 5 minus square root 2. By following the rule, you should multiply the top and the bottom by square root 5 plus square root 2, as like this. The top, the numerator, you have square root 5 plus square root 2 multiplied by square root 5 plus square root 2 again. The bottom, you have square root 5 minus square root 2 and multiplied by square root 5 plus square root 2. Now the top and the bottom, you will need to expand, open up the bracket. You have 5 plus square root 5 square root 2 plus square root 2 square root 5 times 2, and the bottom you have left with 5 minus 2. Why 5 minus 2? This is just a square minus b square formula. Simplify the value, and you have 7 plus 2 square root 10 over 3. That will be the answer required for your A-level. Thank you.